Here is a numerical problem from the chapter electricity. So it's an important question based on examination point of view. So it's not one question, it's in fact two questions. So I'm just putting these questions as A and B. So the first question states, a given wire is stretched to double its length. We have to tell how the resistance changes, means we have to tell what happens to the new resistance. And the second question, the B bit, is a given wire is doubled on it. See, the first question is a given wire is stretched and its length is doubled. The second one is a given wire is doubled on it. That means it is folded. And in this case, we have to tell how its resistance changes. How its resistance changes meaning is we have to tell what happens to the new resistance. So the two questions look alike, but they are not alike. In the first case, a given wire is stretched and its length is doubled. In the second case, a given wire is folded on it, doubled. That means its length is in a way halved. And we have to tell what happens to the new resistance. So coming from the coming board examination point of view, these two questions are very valuable. So I felt I should make a video on this. So I'm answering the first question. So according to the question, there was a wire of length L. So it is the same wire. So material of the wire will not change. So resistivity rho before and after. This wire had some resistance. Okay, so it had an initial length L1. And resistance R1, and it had some area A1, and the same wire is stretched and doubled, length is doubled. So the new length is L2, which is double the initial length, that is twice L1. Material is the same, so resistivity is rho. If length or area changes, the resistance definitely changes. So the new resistance be R2, and this is what we are supposed to find. R2 we are supposed to find. And if the wire is just stretched and its length is double, the wire thickness reduces. Length double means thickness reduces. So area also changes. So the new area is A2. We are supposed to find the new resistance R2. What happens to R2? So what we do is we write two equations of resistance. We know that R is equal to rho L by A. So in the first case, when length of the wire was L1 and the wire had some thickness or area of cross section A1, the wire had some resistance R1. So this is our first equation. Coming to the second equation about the wire when it is double. The new resistance is R2. So R is equal to rho L by A. This we know. So if length is doubled and area is like some new area, so A2, then resistance also doubled, resistance also changed. So this is the new resistance R2. Then this is a rho. L2 is what? L2 is twice L1, and we have no information about area. What happened to the area? We don't know. So let this be equation 2. Now here one point to be understood. The point is before and after the volume of the material remains same. If just we have stretched and increased the length, the wire thickness reduced though, but the amount of metal of the wire, means the volume of the wire is same. How do we calculate volume? Volume is equal to length into area. So when the length was L1, area was A1, volume was V. So from this expression, we will find the expression for area of the wire in the first case when it was not stretched. So A1 is a V by L1. Similarly, we can write A2. A2 is a V by L2. But what is L2? L2 is twice L1 because length was doubled. This is it. So these are the expressions for area. Now when we have to tell what is the change in resistance, its meaning is we have to tell the new resistance in terms of initial resistance. For that purpose, we have to compare equation 1 and 2. So we are dividing equation 2 by equation 1. So divide left hand sides and divide right hand sides. So R2 by R1. First we'll write the fraction of R2 or equation of R2, which is from equation to right side. That is a twice rho L1 by A1. But what is, by A2. What is A2? A2 is V divided by twice L1. So here that is the fraction for R2 divided by R1. R1 means we will multiply the reciprocal of R1's right hand side equation. That is from equation 1 you pick up R1's equation. So that is going to be A1 divided by, see this I am talking about. Okay, so A1 divided by rho L1. And what is A1? A1 is a V by L1. So V divided by L1 by, that is A1 by rho L1. So this is the expression. Now solving it further. So the first fraction twice rho L1. Denominators at twice L1 also comes to the numerator. This is how we do when we divide fractions, by V. And the second fraction, numerator V by L1. So that L1 goes to the denominator, that becomes a rho, which was already rho L1. One L1 adds up to the denominator. Now see what things cancels off. So rho L1 into L1 is rho L1 square, cancels with this. V cancels, and numerator we are left with only 2 into 2. 2 into 2 is what? 4. 4 by 1. So R2 by R1 is 4 by 1. So hence R2 is 4 times R1. So the question was, if a certain wire of a certain length and certain thickness is stretched and its length is doubled, then what happens to the new resistance? The new resistance becomes 4 times the initial resistance. Now coming to the second question, which looks very similar to the first question, but it is not so. The second question is, a given wire is doubled on it. So let the given wire be this one, whose length is L1. It is of a certain material, so it has got a resistivity of rho. It has a resistance of R1 and a certain thickness A1. This wire is doubled on it. See the second diagram that I am drawing. Doubled on it means it was folded over itself. This is called doubling on it. In that case, it has got a new length L2. L2 is actually, when you fold a wire holding the two end points, the length becomes half of the initial one. So L2 is actually half of L1, means what? L1 by 2. So the material is the same now also, but the resistance has to change. Why? Because length is reduced and area also changes. It becomes in fact thicker. So area is A2. Now we have to find what happens to the new resistance, means R2 in terms of R1. So we have the formula R is equal to rho L by A. So the first case R1, L1, A1. This is our first equation. And so the second case R2. R2 is rho L2 by A2. So we know L2 is L1 by 2. But what about A2? For that, we come to the volume expression. Volume is length into area. So from here we can write area is a volume by length. So A1 is a volume by L1 and A2. Second case wires length area of cross section. That is volume of the wire by the new length, that is L2. L2 is L1 by 2. So this we are going to use. Okay. So R2 is a rho L1 by 2. And what is A2? A2 is volume by L2. L2 goes to the numerator and L2 is L1 by 2. So L1 and by 2. So this is how the R2 expression looks like. So I just do a little changes in the R1 expression where let me write A1 value. So what is A1 value? A1 is a V by L1. So L1 goes to the numerator, that becomes rho L1 into L1, that is L1 square. So these are the two equations for the resistances. Okay. So since we have to find R2, Let's compare equation 1 and 2. Let's divide equation 2 by 1, dividing left hand sides and dividing right hand sides. So it is R2 by R1. So we'll first bring in R2's expression, that is rho L1 square by 4 times V. If a wire is just folded over it, means doubled on it, its volume is not going to change. So that is why we will not write V1 and V2. It's only V. That is R2 expression. To this we are multiplying the reciprocal of R1 expression, that is a V by rho L1 square. Now what stuffs cancel? Volume cancels, rho L1 square cancel, and we are left with 1 by 4. So finally what to conclude? We can conclude that R2 by R1 is a 1 by 4 or R2 is a 1/4 of R1. So from the two questions, we have learned that if a given wire's length is doubled just by stretching it, the new resistance is 4 times the initial resistance. But if a given wire is doubled on it, means just folded by holding end to end, its length is halved, then the new resistance is 1/4 the initial resistance. So here if we know the initial resistance, we can tell the value of the final resistance. Hope this video is very useful for the coming board exams. God bless.